Welcome to lesson 40, Gaussian elimination. This is one more way of solving systems of equations that we're going to look at. Now, to motivate this, think about where we've been. We've first started solving systems by the graphing method, and that method works really well. If you have a 2x2 system, it doesn't work really well for a 3x3 system. Why does it work for a 2x2? Because in a 2x2 system, you've got the equations of lines. Whatever. You've got equations of straight lines. And straight lines, you can graph straight lines, and you can look for where they cross. And where they cross, that's the solution to the system. So it works great for 2x2. Then we looked at the substitution method. And after that, we looked at the addition method. And these are both really good for 2x2s or even 3x3s. Maybe 4x4s. I'll put a question mark. They give you the exact solution. That's a heck of a bonus, right? Because you're solving algebraically, you're getting exact solutions. But and plus you can do something bigger than a 2x2. You can do a 3x3, which is what we did. You could probably do a 4x4 without too much hassle. But you can see where you wouldn't want to go much longer than that, much larger than that. So I'm going to say these are great methods for small systems, 2x2s, 3x3s. What we want, our goal today, is to develop a method that is easily extended to very large systems. Very large systems. Things like, a 12x12. You'd want to be able to do a 12x12. Or maybe a 50x50, you'd want to be able to solve that, or maybe a 100x100, or maybe even a 9, well, I don't know about that big, but let's call it 1,000x1,000. I was going to say 9,000x9,000. Maybe 1,000x1,000 is about as high as you'd want to go with this. I don't know. Then there's other methods you could look at. But anyway, we want to develop a method that is easily extended to very large systems. So to make it extendable, I guess, what we want is something that's a real step-by-step. You're always going to do this first, and you're always going to do this next, and you're always going to do this next. What we're going to do, just to give you an idea of how it could be extendable, is we're always going to start with whatever system of equations they give us. We're always going to start at the upper left. We're going to take whatever x term they've got there, and we're going to turn that into a 1x. Just a 1x, and the rest of the equation can be whatever it wants. Then we'll come down here, and we'll get rid of the x so that it's not there anymore. So we'll have some kind of y terms and whatever else. But get rid of the x term. Now, if this were a bigger system of equations, we'd next, we'd next come down to the, if there were a third equation, we'd come down to this third equation, and we'd make that a 0. And if it was a 4x4, we'd come down to there and make that a 0, right? So the idea is you can go down as many lines as you want, and that's what you would do. You would make the top into an x, and then you would get rid of the x terms from all the equations below. When you got that done, you'd come up to here, and you would turn that, maybe I get a different color going here. I'll stick with green. No, let's stick with red. Okay, I would turn that into just a 1y. Okay, just a 1y. Kind of the way I turn that into a 1x, I turn that into a 1y. And then if there were any other equations, I'd get rid of the y term from that one, I'd get rid of the y term from that one, all the way down to the end. If we had a z term, our next step would be to come up here and make it into a 1z. You know what I mean? So that's kind of the idea. How are we going to do that is the next question, of course, but that's our plan. So what's nice is you're going to cross the matrix in the same way every time. Start here, go all the way to the bottom. Start here, go all the way to the bottom, and so on. Now, this being a 2x2, we're not going to have to do quite so many steps. Maybe I'll leave that stuff up. I might leave this stuff up. Maybe just put like a little line around it. Or you know what I'll do? This is great. I love this. I love this. Come on, you. I can shrink it. Ain't that cool? I love that. Gotta love it. Okay, so anyway, let's start solving this thing. Now, actually, I should probably mention, I put this question here, how would AI solve this thing? And it occurs to me now that that's kind of a lousy question. Because what would AI do? AI basically scans the entire internet of billions and billions of pages, and probably it would find this very problem out there somewhere, and it would say, oh, that's the solution right there, and it would just copy it. So AI was not going to be very interesting. So we want to think in terms of we're programming a computer to do this. So what steps do we tell the computer to do? Okay, so that's really what I wanted to do, is get you in a computer programming frame of mind. That's what I meant to do. So here we are in our computer programming frame of mind. Now remember our idea. We want to make that into an x, just a regular x. How are we going to do that? Well, first of all, we used to call this equation 1 and equation 2. We're going to do this slightly separately. We'll call that row 1 and row 2. Row 1 is still an equation, of course, and row 2 is still an equation, of course. That doesn't change. But how would you change that 2x to an x? Now you have to think in terms of you're monkeying with an equation here, right? You can't just change the 2x and ignore the 3y and the 10. They all have to change together. It's an equation. You have to do the same thing on both sides and all that. You got to be legal about this. So think about row 1. Row 1 is this, 2x plus 3y equals 10. And what we want to do, again, is make that into a regular x. Come on, you. And what we can do is we can divide the whole equation by 2, right? That's a legal move. So what I've done, you might even write it this way. I've taken row 1 and I've divided it by 2. That's our move. That's our move. Row 1 divided by 2. And when we do that, what do we get? Well, 2x over 2 is just an x. 3y over 2, you could write that as 3 halves times y equals, and then the 10 over 2 is a 5. So that's our new and improved row 1. Now row 2 is the same, and we'll just kind of copy it underneath here and say there, we've made one of our first change. We've made our first change. Cool. Next, remember, next up is to change this into a 0, or in other words, make the x term go away. So this is our second maneuver here. What are we going to do? Well, how do you make an x term go away? It wasn't that long ago that we were doing that all the time, right? Wasn't that called the addition method, where you make an x term go away by saying, well, let me take this equation, maybe I'll make that into a negative 3x, and then I can add the two equations, right? So what we'll do is we'll take, maybe I'll write down the move, and then I'll actually do it. We're going to take a negative 3 times row 1, and then we'll add row 2. So negative 3 times row 1, that means negative 3 times x. That means negative 3 times 3 halves, which is negative 9 halves y. And negative 3 times 5 is a negative 15. Row 2 as is. So we'll just copy that underneath here. And now we can add these things. And lo and behold, the x terms go poof. Cool. Now let's see, negative 9 halves minus 2. Well, 2 is 2 over 1, which is the same as 4 over 2. So we get a negative 13 halves y, and then over here that's a negative 26. That's our new and improved row 2. So what's our system look like now? Well, again, we didn't change the top equation. I mean, we changed it here in our scratch pad, but we didn't change it in the computer's memory banks. So we go like this, x plus 3 halves y equals 5. This equation is done. We did what we wanted to do. We made an x term. We're never going to actually change the memory banks anymore for that row. But instead of writing this, we're going to write this. So we have a 0, which I just won't write it, 0x, and then we have this negative 13 halves y equals a negative 26. Cool. That's what our memory banks look like now. Let me double check, make sure I'm on the right track. Good, I'm on the right track. What's our next goal? We made that the 1x, we got rid of that x term. Next, we want to make that into a 1y. And how do you make that into a 1y? Well, you can, remember it's an equation. How can you make this equation, change the equation so that it's a 1y? Well, I'm going to maybe put this move up here someplace. What we could do, our move, is to multiply both sides by the reciprocal. Multiply both sides by a negative 2/13. So we're going to take negative 2/13 times row 2. So the top equation stays. We're not going to change the computer's memory on that. But the bottom equation, we are going to overwrite this with a new and improved equation. We'll take a negative 2/13, and I'll just do my scratch work right here. A negative 2/13 times the negative 13/2 y. And on the other side, we'll take a negative 2/13 times the negative 26, which I'll put over 1. So over here, the 2 cancels, 13 cancels, the negative cancels. It's a y. And then here, the negative cancels. Will you not do these weird things? Go down. How do you get this thing down? Go down. Get out of here. Scram. Scram. Beat it. Beat it. I don't want a split screen. What are you doing to me? Okay. Yeesh. Never tap the screen if you don't mean to tap the screen. Okay. Where were we? Over here. So we were over here. So we can cancel 13 into 26 twice. So that's over 1 over 1. So basically we've got a negative 2, and remember that's a negative right there, right? So negative 2 times negative 2 makes that a 4. There. We have finished monkeying around with our system of equations. The only thing left to do now, this is going to sound funny, the only thing left is to solve it. Well, the way you solve it is first, just take a look at the bottom row there, row 2. It has one of your solutions, y equals 4. So how do we solve for x? Well, you just got to take that solution and come back up to this row. Bring it with you. So the row 1 says x plus 3/2 times y, and we just figured out that y is 4. I'll write 4 over 1 equals 5. So we can kind of finish this up. Cross cancel 2 and the 4 twice. This says x plus 3 times 2 is 6 equals 5, and so x equals a negative 1. And so our solution is x is negative 1, y is 4. Is that what I got before? Oh, yay. Good. That's what I got before. I must have done it right. Cool. Pretty cool system, huh? Or, approach. Pretty cool method. Again, it's easily extendable. That's the value. Okay, it's a little fractiony. You may have noticed. It gets a little fractiony, but that's okay. That's okay. Now I want to do a replay. This is the same problem, but I want to be more official about it. Turns out there's a whole, almost like a lingo that goes here. We got some terms to learn like augmented matrix, row operations, row-echelon form, back-substitution. What do all these things mean? Plus there's a bit of a notation that we need to learn. So the good news is we're going to go through the same steps again for a bit of reinforcement, but while we're at it, we're actually going to do this like all official like. So the first thing we do, you see that system? I got a simpler way to represent that. And who doesn't want a simpler way to do something, right? Here's a simpler representation. What matters really are the numbers. The 2, 3, the 10, the 3, the negative 2, the negative 11. Now what we do is we put this in sort of a matrix. That's what these kind of bracket bars are telling us. It's a matrix, and also draw a line right here. This is called an augmented matrix. What's so augmented about it? This part is, because what we have here is we have coefficients 2x plus 3y, 2x plus 3y equals 10. So it's like this stands for the equals part of the equation. Underneath we got 3x, there's the 3, minus 2y, there's the minus 2, equals, so on the other side of the line, a negative 11. Okay, so let's see if I can get rid of all that stuff. Cool. Okay, that's called an augmented matrix. Our goal, by the way, let's put this in a different color, is to change this into something called row-echelon form. What's row-echelon form going to look like? Well, remember, we're going to take the x and turn it into a 1x, so that's going to be a 1. We're going to this number can be whatever the heck it ends up being. This number could end up being whatever it is. But then we wanted this x term to go away, which is going to make that a 0. And then we also wanted to make that y term into a 1y, so that's going to be a 1, and this could be whatever number. Okay, this is called row echelon form. Notice its properties here. We got 1s going down the diagonal, and if it were a bigger system, it would just keep going on down. We'd have a 1z and a 1 whatever comes after z, and so on. And we'd always have everything underneath would be zeros. Okay, that's the idea of row echelon form. 1s down the diagonal. Might be worth writing this down. Back to blue. 1s down the diagonal from northwest down, zeros beneath the diagonal. Everything else can be whatever number it needs to be. Okay, that's our goal. And to get there, we do what's called, maybe I'll do this in green, we do what's called row operations. So every time we change a row, we say, hey, we're doing a row operation. Let's do the row operations. Okay, so let me get this stuff out of here. Now our first, let's do it this way. Our first target is this, right? Make that into a 1. And in the background, you have to keep in mind, this row 1 represents an equation, right? So you have to think of changing the 2. Really, you have to think in terms of, I'm changing this 2x into an x for this equation. And so the row operation that we did, remember we divided the whole equation by 2. So here's a notation we're going to use. We're going to use a capital R1. That stands for new row 1. The new row 1 is going to be the old row 1, the little r, the old row 1, divided by 2. That's what we're going to do. Okay, so again, think back. What are we doing? We're taking this 2x plus 3y plus 10 and we're dividing every term by 2 because that's legal. And it'll give us our 1x just like we like. So one of the reasons they call it a row operation is because we just kind of do that to all the numbers in the row. Get it? So we're taking the 2 and we're dividing it by 2 to get a 1. We're taking the 3 and we're dividing it by 2 to get a 3/2. We're taking the 10 and we're dividing it by 2, dividing it by 2 to get a 5. There, we just operated on row 1. We did not operate on row 2, so just copy those back in there. And that's what our augmented matrix looks like now, because we did a row operation. We got our 1. Cool, cool, cool. Let me see if I can get this stuff out of here. Our next target is to make that into a 0. So remember that you do that by adding equations together. So we're going to change row 2. So I'm going to write my little equation or whatever here that says row 2, the new row 2, capital R, the new row 2 will be, what am I going to do? I'm going to actually have to take -3 times this row and add this row to it. So -3 times row 1, which means equation 1, and add row 2 to it. That's our row operation. Now, what you want to try to do is save yourself the effort of writing out the entire equations and just do this all the way across the row. So what does that mean? It means, well, let's see. Yeah, good enough. It means, for example, take -3 times this and add this. What is that? -3 times 1 and add 3. So of course we get a 0. Now, I probably should have written row 1 in here first because we're not going to change it. So what we are changing is we're making a new row 2. So again, back to my first column. -3 times 1 is -3. You add 3, you get 0. You can put the 0 there. Now do the same thing over here. -3 times that, -3 times 3/2, that's like a 3/1. And add that, which means add a -2. So what is this going to get me? Well, that's a -9/2, and 2 is the same as 4/2. So we're getting a -13/2, and that's what goes there. And then do the same thing over here. So a negative, come on you, a -3 times the 5 plus the, well, plus the -11. So really that's -11. Okay, so that's a -15 minus 11, so that's a -26. And there's our matrix now. Step 3. Remember what our goals are. Now that we've got the 1 there and the 0 there, we're very happy with the first column, but we want to make that into a 1. A 1y really, but a 1. And our row operation is going to be, we're going to change row 2. So these are the instructions for the new row 2, capital R, new row 2. The instructions are, take the reciprocal of that, negative 2/13, and multiply it by the old row 2. And you do that all the way across row 2. So, first row, we are not changing the memory banks at all. Just copy that in. But the next row. Now you really got to do this all the way across the row. So a negative 2/13 times 0 is 0. Okay. A negative 2/13 times a negative 13/2, well, they're reciprocals, so you get 1. And then you got to do a negative 2/13 times that, so scratch work, negative 2/13 times the negative 26. This feels familiar, right? So cancel the 1 into the negative 26 is negative 2. Negative 2 times negative 2 is 4. Cool. Now let me get this scratch work out of here. We don't need that. Behold, row-echelon form. This is your happy time. Row-echelon form. Smile. So now to finish this up, let's come back up to here. We do a process called back-substitution. Substitution. And you may remember from the previous page that the first thing we did is we looked at row 2 and saw a solution, y equals 4. That was cool. Now we take that, y equals 4, into row 1. See, that's what we mean. We back up 1. We start at the bottom, we got a solution, then we back up 1 and substitute, hence the name back substitution. We're backing up and substituting. So, what do we got here? Into row 1. Row 1 says 1x plus 3/2 times y, and here's the y is 4, equals 5. And so we just kind of solve this up. 2 goes into 4 twice. We got x plus 6 equals 5, and so x equals negative 1. So that was our first solution. That's our second solution. Our full solution is the point x equals negative 1, y equals 4. That's where these two lines cross. So, did I get all our vocabulary in? Let's double check. Augmented matrix, right? That's this. You're just taking your system of equations and kind of, extracting some, just extracting the key info. The numbers are what matter. Row operations, that's these things. Notice there's two kinds of row operation. What do you do when you need to make a 1? Well, you usually divide, or in this case we multiplied by a reciprocal. And then the other kind is the kind you need to make a 0, and that's where you have to add two rows together, kind of like adding two equations together. So there's two kinds of row operations. Row-echelon form, yep, that's where we got the 1s on the diagonal, the 0 underneath. Back substitution, that's what you do at the end to finish up and get your actual solution. Cool. All right, so I want to do one more example. Yep, one more example. And to show you how this extends so nicely, we'll do it up a 3x3. Now you wouldn't want to do a 5x5 or a 10x10 by hand using this method, I don't think. But I hope you can see where it can be easily programmed. That's our main goal. Say, oh, this kind of works. Now actually I have seen students come to prefer this method for 3x3, so maybe that's you. I don't know. Maybe you'll prefer this method. So, a 3x3 system, huh? Okay. First, we'll make the augmented matrix. Just take these numbers out, basically. So we got a 2x, a negative 1y, a 4z equals a 6. I'll be putting a line here in a little bit. We got a 1x, a 2y, a minus 2z equals a negative 5. We have a 4x, a 3y, an 8z equals a 2. So I like to put this line down. I like to put all my numbers there first, and then my bracket will be the right size. So there's our augmented matrix. Our plan of attack. Start at the top left. Make that a 1. Make that a 0. Make that a 0. Make that a 1. Make that a 0. Make that a 1. Okay, that's how you get to your row echelon form. So let's just kind of see this in action. Here's my target. Okay, so maybe I'll say something like target the 2. You want to make it into a 1. Make it a 1. There we go. So what row operation will we use? Well, we're going to make a new row 1. So capital R1 is going to be, take the old R1 and actually, once more, divide it by 2, right? So you have to think in terms of I'm dividing the top equation by 2 all the way across. If you want to call it a row operation, fine, but make sure you're doing the operation all the way across the entire row. So row 1 divided by 2, 2 divided by 2 is a 1. Negative 1 divided by 2 is a negative 1/2. 4 divided by 2 is a 2. 6 divided by 2 is a 3. Okay, and those are the changes that we're making to row 1. We're not going to change row 2, so copy it. We're not going to change row 3 right now, so copy it. Put the line there, put your brackets there, and we've made some progress. 1 down. 1, 2, 3, 4, 5 to go. So it's a little bit longer of a process when it's a 3 by 3, but that's okay. Step 2. Our target this time is this. We want to make that into a 0. So you started at the upper left, and now you're going to keep going down until you've made all zeros. So I'm going to say target that 1. We want it to be a 0. And you do that by adding equations together. So let's think about the row operation for a second. First of all, we're going to change row 2. So capital row 2 is going to be what now? Well, come up here and say, well, if I wanted to add these two equations together and have x go away, I need to make one of these negative. Now, convention is to always change the top row, the one above you. So we'll take a negative row 1 and add row 2 to it. Okay, that's going to be our move. Again, convention is to change this equation. You want to add this equation as is. That's always what we do. Because we're being a computer programmer. We want to do it the same way every time. So, what does that look like? Well, here you would take a negative 1 and add 1 and get a 0. Cool. See, it's going to work. Now, actually, let me first, since we're not going to change row 1, let me copy those numbers in. And now we'll start to change row 2. So once more, a 1 times a negative 1 is negative 1. Add 1, 0. Okay. Negative 1 times this is a positive 1/2. Add 2. That'd be a 2.5. 2.5 is the same as 5/2. Improper fractions are better. Okay, a negative 1 times this is a negative 2. Add this. You got a negative 4. A negative 1 times this is a negative 3. Add this, you have a negative 8. And then the third row is the same for now. Put my line here, put my brackets here. Okay, we've made some progress here. Let's get this stuff out of here. Bothers me. Okay. Oh, wait, bother me. Okay. Making progress, making progress. Next, make that into a 0. Well, I think I'll just kind of keep going down here. So step 3, target that 4. We want it to be 0. So we're going to change row 3. So what's our new row 3 going to be? Capital row 3, our new row 3 is going to be. Now once more, you make zeros by adding two equations together. We're always going to do something to this equation and add this equation to it. That's always how we do it. So notice we need to multiply that equation by a negative 4 in order to make this a negative 4, which when you add 4, it'll go poof. So negative 4 times row 1, add row 3. That will be our new and improved row 3. So row 1. Row 1 is actually done. We're done with row 1. Row 2. At the moment, we're going to leave it as 0, 5/2, negative 4, negative 8. Row 3. Well, now we're making the changes, right? So all the way across the row. Negative 4 times this is negative 4, and you add this, you get 0. That's what we wanted. Negative 4 times negative 1/2 is a positive 2, plus 3 is a 5. Negative 4 times this is a negative 8, plus this is a 0, actually. Negative 4 times this is a negative 12, plus this is a negative 10. Put my line in, put my brackets. See, now we're getting somewhere, right? We got the 1, we got the 0, we got the 0. 3 down, 3 to go. So what's our target now? And if you don't mind, I'll just keep scrolling down. Our target now would be here, actually. Come back and we want to do the second column. Now you start, down here because we want that to be basically a 1y. So I'll write this target, the 5 halves, make it a 1. How? We're going to change row 2, right? How? We're going to basically divide by 5 halves, or what means the same thing is multiply it by the reciprocal. So we're going to multiply row 2, the whole row 2, by 2/5. So row 1, put that back. That's the same as always. Row 2 is now changing. 2/5 times row 2 means 2/5 times this, which is 0 of course. 2/5 times this is 1. 2/5 times this is negative 8/5. 2/5 times this is negative 16/5. And row 3 we're leaving alone for the moment. Okay. Next. This wouldn't be a bad time for you to pause the video and try to do this next row operation yourself. Formulate what is the row operation we need to do, and then do it, and then make sure you match. So, what am I going to do? We want to change row 3. I'm going to make the 5 into a 0. So, row 3 equals. Now you do that by multiplying equations together. Now here's where the 1 is. That's helpful for you, right? So you take a negative 5 times row 2 and add row 3. That's what you want to do. What's this going to look like? Row 1, not changing. Copy. 1, negative 1/2, 2, 3. Row 2, not changing. Copy it. 0, 1, negative 8/5. Oops, negative 16/5. Row 3, yeah, we're changing that one. So you have to do this all the way across the row, all the way across. Even here. Negative 5 times this plus this. Well, that's a 0 plus a 0, that's still a 0. Negative 5 times this is negative 5. Add 5. Yay, we got our 0. Negative 5 times this. Well, the 5s are going to cancel, right? The 5 and the 5 in the denominator are going to cancel. So a negative 5 times a negative 8/5 comes out to be a positive just 8. And then same thing here. When you multiply fifths by a 5, the fifths just cancel. So a negative 5 times a negative 16/5 is basically a 16. Add the negative 10 to it, and you've got a, what did I say, 16? Yeah, 16 minus 10 is a 6. There we go. Put your line there. Put your thing here. Okay, we are almost done. We are getting there. We are getting there. In fact, let me do this. Let me, well, no, I'll stay blue. But let me come up over to here so we can have more of our stuff visible on the screen. So our target now is this. We want to make that 8 into a 1. So we're going to change row 3, and our instructions are basically divide row 3 by 8. That'll do it. So remember, to make a 1, you're always doing a divide or a multiply by a reciprocal. To make a 0, you always have to add equations together. So making the zeros is a little more involved, but making the 1s is usually kind of fun. So I'm dividing row 3 by 8. So row 1 has been done for a long time. 1, negative 1/2, 2, 3. Row 2 is now finished. 0, 1, negative 8/5, negative 16/5. Row 3 is changing all the way across. You want to divide by 8. 0 divided by 8 is still 0. 0 divided by 8 is still 0. 8 divided by 8 is a 1. 6 divided by 8. 6/8 reduces to 3/4. Put your line there. Go like this. And then go like this. Yay, I've reached row echelon form. Once you've reached row echelon form, all that's left is to solve it. I find that humorous. All that's left is to solve it. Okay, so you start at the bottom. This is going to be called back-substitution, by the way, because you're going to keep backing up, backing up, backing up. But you start at the bottom. So starting at row 3, well, row 3 is really just says 0x, 0y, just 1z equals 3/4. So that's one of our solutions right there. Put that into row 2. You always back up one level at a time. So I started there, take that answer up to here. So I got 0x plus 1y minus 8/5 times z, which is 3/4, is equal to a negative 16/5. Okay. Well, let's see now. I can cancel the 4 into the 8 twice. So I've got y equals negative 2 times 3 is a negative 6/5. Not equals, I'm sorry, I copied that wrong. So y minus 6/5, that equals negative 16/5. So okay, if I add 6/5 to both sides to get that to go away, what am I looking at? I'm looking at y equals negative 10/5, which of course is negative 2. So that's our second answer. Y is negative 2. And now, oh, come on, man. Okay, so now we take both of those and we come up to the top equation and plug into that one. So maybe I suppose I could do that here. So let me, actually it's the same top equation here. So I can look at that. We've got an x minus a 1/2 y plus a 2z equals a 3. That's what the top equation is. So x minus 1/2 times y, but y is 2, plus 2 times z, but z is 3/4, equals 3. 2's cancel. That says x minus 1. 2 cancels into the 4 twice. So that says plus 3/2 equals 3. Okay, let's make everything halves. 1 is the same as 2/2 plus 3/2. 3 is the same as 6/2, right? If you divide 6 by 2, you get 3. So what do we get then? We got x equals, we got the 6/2. We're going to subtract 3/2 on both sides to get rid of that. We're going to add 2/2 on both sides to get rid of that. So x equals 6 minus 3 is 3 plus 2 is 5. Wait a minute. I got him stuck here. I got him stuck. Let me find it. X minus 1/2 y plus 2z equals 3. Okay. X minus 1/2 times y. Y is negative 2. Sorry about that. Let's fix this in red. Y is negative 2. That's a negative 2. So when you multiply a negative 1/2 times a negative 2, you get a plus 1. And because it's a plus 1, what did we do over here? We didn't add 2/2. We subtracted 2/2. So 6 minus 3 is 3, minus 2 is 1. That's better. I know that's the right solution. Go. X equals 1/2. And so our full solution is x is 1/2, y is negative 2, z is 3/4, right? Right. Cool. Alrighty, and that's our idea. This is called Gaussian elimination, and you can easily, you wouldn't want to do it, but you can easily see how you could solve a 20 by 20 system. You'd make a 1, you'd make all of these into zeros. You'd come up into here, make a 1, make all of these into zeros. 1, make all, and the good news is there's only 2 kinds of row operation. You're either making a 1 or you're making a 0. Back substitution is how you finish it all up at the end. Well, I hope you think this is kind of a cool method.